Hello everybody, welcome to my class. So let's do a problem from vector grade 10 optional mathematics. So here you can see we have a lot of problem over there. So before you deal with this sort of problem, you should have pre-knowledge of or the general idea of vectors theorem, and this is also kind of vector theorem which was asked in SC examination, and also this sort of question has been included in the CDC grade 10 optional mathematics paper. So here let's do this problem. You can see the problem states that by using vector method, prove that the quadrilateral formed by joining the midpoints of adjacent sides of a quadrilateral is a parallelogram. So you can see here that this is ABCD is any parallelogram. So if you talk about adjacent side to AD, that is AB. Similarly, adjacent of BC is AB, and also here CD, and this way adjacent means the side by side, and they join the vertex and they are called the adjacent sides. And question says that actually you can see here that by method prove that the quadrilateral formed by joining the midpoints of the adjacent sides of a quadrilateral. Adjacent side of the quadrilateral means let's join these two midpoints for these two sides. Okay, so this way you can join this side, these two adjacent side, and also you can join the midpoint of these two sides, adjacent side, and also we have these two adjacent side, and this is the midpoint. Yes, and then this is, in fact, it is also a midpoint. So you can call this as PQRS, or otherwise what you can write here, this is first midpoint M1, M2, M3 and M4. And so what you have to prove actually, that you have to prove, okay, you have to prove that the quadrilateral, you can check here, M1, M2, M3, M4 is a parallelogram. Alright, so in order to prove that this newly formed parallelogram as parallelogram, there must be opposite sides are equal and parallel. So what you can write here is that before doing so, let's draw a reference line. You can either join these two lines or you join these two midpoints which are opposite to each other. It's okay? Each other. Yes. So when you join this line opposite to each other, then what can you find here is that if you consider this line or this line, so in that way, can you do something for that? Yes. This is M1, M2. And this way, I don't know whether it works or not. So what you have to do actually that you join this line. Yes, from here to here. So if you join this, what happens in that case? So this is the, if you consider, or this is also possible that you join whole thing from A to C. So this is a good idea now. So by midpoint theorem in a triangle, what you have seen that actually in a triangle, you have seen that here M4 relation between BD and M1 M4 is actually BD double of M1 M4. So in that case, what you can write here, that I am taking the reference of triangle ABD. So what you can take here, that triangle ABD. Yes. You can write here that M1 M4 vector in vector sense, vector M1 M4 equals to the vector half of vector BD. It's okay? M1 M2 half of vector BD, both in direction and magnitude. That is what we have actually, the magnitude of M1 M4 vector as it is half of magnitude of BD. It's okay? You call this as equation 1. And similarly, in triangle, you can just go behind below of this previous triangle ABD. So now in triangle CBD, in triangle CBD. So make sure that you have to take the vector in the same order, like M1 M4, then you can write BD. If you write M1 M4 equal to DB, that there should be negative sign. Alright, here. So in that triangle you again have now M2 M3. So vector M2 M3, relation between vector M2 and M3 is half the vector BD, half the vector BD. And also in magnitude, they have the same magnitude and along the same direction. Okay, so how you can write here is that magnitude of M2 M3 equals to half the magnitude of vector BD. It's okay. So this is 2. Alright. So therefore from 1 and 2 you can see that M2 M3 is half of BD, and here M1 M4, here M1 M4 is half of BD. So therefore you can say that from 1 and 2 vector M1 M4 both in direction and magnitude equals to your vector vector M2 M3, they are equal. So these two vectors we have seen that, these two lines we have seen that they are equal in magnitude and also they are along the same direction. It's okay. And you call this as 1, 2, 3. And similarly if you join A and C like this, A and C, and go through the similar process that you don't need to show it again here, you can directly say that vector M3 M4 in both magnitude and direction, what I have taken M3 M4, so you can take here in the same order M1 M4 M1. So this is M4 M1. That vector is, those vectors are also equal in magnitude and having the same direction in this case. So this you can call this as equation 4. Now what we have, you see here now from equations 3 and 4 you can see that in the quadrilateral M1 M2 M3 M4, okay, opposite sides are opposite sides are parallel and equal. Yes, therefore the quadrilateral M1 M2 M3 M4 is a parallelogram. Alright, and hence this is proved. Okay guys, I hope this sort of applying sense to the vector problem will help you solve a further problem that relates proof sort of thing like this. So vector always seems, usually seems it is difficult, but it's not that difficult actually when you truly understand the path of the line and how their directions and the magnitudes work together. In that case, if you are confident in those areas, the problems from vector are not that difficult. Okay guys, this is all for now, and thank you for watching.